All right. So looking at this, Darren bends a piece of wire around us using a circular disc to make the shape shown. How long does the wire need to be to make the shape? So how long is the distance from here to here? That's what we're wondering. Well, in a circle, do we know the distance all the way around and outside of the circle? What's that called? Circumference. The circumference is the distance all the way around the circle. It's the same as the perimeter of the circle. The circumference of a circle is 2 times pi times the radius. Okay? Do we know the radius? Okay. So the radius is 22. So the distance around the entire circle is 2 times pi times 22, or 44 pi. Okay? Now, how much of the circle are we going around? A fourth of it. How do you know it's just a fourth of it? You're right. You looked at it. Good job. The right angle. Okay? How many degrees are in a circle? So if we went 90 of the 360 degrees, it would be 1/4 of the circle. So from here to here is 1/4 of 44 pi, or 11 pi. What's 11 times 3.14? Okay, approximately 34.54 centimeters is that. Okay, all right. Arc measure. If you know what's called the central angle, and last problem right up there was 90 degrees. If you know your central angle will help you determine how long this arc measure is. Okay, will help you learn how long this arc measure is. Now, if these two arcs are equal, these two central angles are equal. That's what this is saying here. Okay? So, if this is 95 degrees, this is 95 degrees. Okay? The central angle is the same as the arc length, as far as the arc measure in degrees. Now, AB is called a minor arc from A to B. If you go around the outside, you need at least 3 letters, which is a major arc. Okay? So, how many degrees are in a circle? 360. What is ACB then? 360 minus 95, which is 265. So ACB is 265, AB is 95. If it has 2 letters, it's a minor arc. It's less than 180. If it's 3 letters, it's a major arc or a semicircle. So it's 180 degrees or greater. How big is XZ? 115. And how big is XYZ? 360 minus 115, which is 245. Okay? So, arc length is a fraction of the circumference, which we just got done doing above. Okay? So, if you take the angle, divided by 360, because there's 360 degrees in a circle, times the circumference, you get what's called the arc length, which is S. Okay, why they use S, I don't know, but they use S. Now, where things get a little more complicated is when we start using radians. A radian is equal to the measure of a central angle that intercepts the arc with the length equal to the radius of the circle. That is your first vocab word on your vocab sheet, so write it down. All right. So let's say the radius of this circle is 4. Then the length of this arc right here would be 4 radians. Okay? So the radians match the radius. Okay? Now, there are 2 pi radians in a circle because 2 pi times the radius is equal to 360 degrees. So pi radians equals 180 degrees. Okay? So in a half of a circle, so if we have a circle, we have a half of a circle. To get from here to here is pi radians. Okay? Which is 180 degrees. Okay? So if you want arc length and you have radians given to you, it's just the radians times the radius. Okay? So the arc length formula is super simple if you have radians given to you. Okay? Or if you have degrees given to you, it's this, which is on the board right here. Arc length, if it's in geometry terms, in degrees terms, it's x over 360 times 2 pi r. If it's in trig terms, because radians is a trigonometry thing, you just take the angle times r. So let's look at that. Okay. What is the length of AD? Okay, AD is right here. Well, how many degrees do we have? Well, what's 104 plus 43 plus 73? These add up to 220, so this is 140 degrees right here. Since it's given to us in degrees, we have to use the geometry formula. 140 degrees over 360 degrees, the fraction of the circumference of the circle times the circumference of the circle, 2 times pi times the radius. Okay? The radius is 4 because of that 4 right there. Okay? So they want the answer in terms of pi. Well, these cancel, and 14 over 36, 2 goes into each. That's 7/18 times 8 pi. Well, 8 goes into 18, 4, and 9 times. So it's 28 pi over 9 is our actual final answer. Okay? Some crazy fractions there. Okay. This is given in terms of radians. So to find the length of JK is just 3 pi over 4 radians times the radius of 5. Well, what's 3 times 5? So it's 15 pi over 4. HK is here. Oh, but how many radians is that? Well, how many radians are in an entire circle? 2 pi radians in an entire circle. So you have to subtract from that pi over 3 radians and 3 pi over 4 radians. Okay? So let's get a common denominator between all these. 3 times 4 is 12. So 2 pi over 1 is the same as 24 pi over 12. 1/3 pi is the same as 4 pi over 12. And 3 pi over 4, if you multiply both by 3, is 9 pi over 12. 24 minus 4 is 20 minus 9 is 11 pi over 12. Okay? If you take that times the radius, what do you get? Eleven times 5 is 55. So it's 55 pi over 12. Okay? Didn't need your calculator for that. Okay, if this radius is 7 and YRZ is 94, YRZ is 94, ZRW is 63, what is WZY? Well, that's this one right here, from here to here. So what do you do with the 63 and 94? Add them up. So it's 157 over how many degrees are in a circle? 360 times 2 pi r. Okay? So you get 2 times 7, which is 14. So 14 times 157 over 360. I think just 2 goes into each. So somebody on a calculator takes 7 times 157. What? 1099 pi over 180. Does 9 go into each of these? I bet no, it doesn't. Oh yeah, 180, not 1080. Okay. There. Okay, a sector of a circle. That should be on your vocab sheet, right? Is the region bounded by 2 radii and the intercepted arc. How do you find the area of a whole circle? No, it's pi r squared. 2 pi r is the circumference. Area is pi r squared. Well, when we're doing a sector area, it's just a portion of the circle, right? How much of the circle is it? Well, it's 78 out of 360, because that's the number of degrees in a circle. Okay? So it's just a portion of the circle. So 78 over 360 times pi times 10 squared. So 100 times that is 7,800 over 360 pi. Zeros cancel in each. I bet 4 goes into each. Take 780 divided by 4 once. What? 195 over 9 pi. That's the sector of the circle. That's how much area is in that pie-shaped piece. What's the area of this one? How do we set it up? 165 over 360 times pi times 3 squared. So take 9 times 165.
1,485.
And then take each of these numbers divided by 5. 1485 divided by 5.
Top one's 297.
That's the area of that space. Okay? So 59 over 360 times pi times 10 squared is 100. So it's 5,900 over 360. So the zeros cancel in each. So it's 590 over 36. Does 590, is that divisible by 4? I don't think it is. 590 divided by 4. No. So you just divide it by 2. 590 divided by 2 is?
295.
295 over 18 pi. That's areas of sectors. The segment of the circle is just a little itty bitty portion. Is a part of the circle bounded by an arc and the segment that joins its endpoints. So we know how to find this whole area here, right? What's the whole area? If this is 60 degrees. That whole area is the area of the sector, right? So 60 over 360 times pi r squared. But if we want just this little part, we take that whole area minus the area of this triangle. Now, because this radius is 8, what's this radius from r to x? 8. Do we have side angle side here? Side angle side area formula. So what I'm going to do is find the area of the sector and subtract from that the area of the triangle. So the area of the sector is is the angle 60 out of 360 times pi r squared. The area of the triangle is 1/2 8 times 8 times the sine of 60. Okay? So what we're going to do is actually use our calculator to get this to the nearest tenth, because that's just what we're going to do. So take 8 squared times pi and hit the pi button on your calculator, and take that times 60 divided by 360. And what do we get to the nearest tenth? Okay? And then take 1/2 times 8, which is 4, times 8, which is 32, times the sine of 60, which I don't know what that is, to the nearest tenth. 1/2 times 8 times 8 times sine of 60. 27.7. And then when we subtract those two, we get 5.8, which would be the area of the shaded region. Okay. Let's do one more of these. What's our central angle there? How many degrees? 90 degrees. So it's 90 over 360 times pi r squared minus, and then 1/2 of 10 by 10 times the sine of 90. So this would be like 50 over here, because the sine of 90 is 1. And this would be 100 times 1/4, so it's 25 pi. Whatever 25 times pi is like 78.5. So if we subtract those two, we get 28.5. That's the area of the green shaded. Okay. Did we do enough of these, or should we do this one? 144 over
360.
times pi times 25, because 5 squared, minus 5 times 5, 1/2 times 5 times 5 times the sine of 144. Okay? So as long as you know how to set those up, that's the biggest thing. Okay? Then just punch them into your calculator. Chen uses circular cork boards to make 18 watermelon coasters to sell at the craft fair. He paints one side of each coaster with a special paint. Each jar of paint covers 200 square inches. Will one jar of paint be enough to paint all of the coasters? Because he just paints one side of the coaster. Okay? So, if this is 72 and he's going to make 18 coasters, okay? So 72 over 360 times pi 8. Ooh, is my radius 8? 4 is my radius squared. So somebody multiply that out and give me a decimal for that. Because it's 16 times pi times 72 divided by 360. What do we get? 10.1? Kendra, you trust those guys? Okay. So if we have 10.1 here, okay, how many coasters is he making? 18 of them, right? If we take this times 18, one isn't it almost 190?
That'd be 181.8. We're just taking 10.1 times 18, right?
Right.
Yeah, 181.8.
181.8. Does he have enough paint to cover all of them?
Yes.
Yes. Because if he has 200, 181.8 would be enough. Okay. He's going to put decorative tape around the edge of each coaster. How much tape does he need for each coaster? So he needs decorative tape for that, plus this, plus this. Well, this part of the green part of the edge is the what of it? The arc length. Okay. So you take 72 over 360 times 2 pi r. So 72 over 360 times 2 times pi times 4. So it's 8. So it's around 7, right? I don't know what it is. Evan has no idea what it is because he hasn't punched anything on his calculator yet. Kendra, what'd you get?
I don't know if I'm doing it right.
So you take
2 times 4 times,
8.
which is 8, times pi, which is like 24,
Yeah, 25.1.
I got 5.
times 72 divided by 360.
Yeah,
5 point what?
0.
Oh, 2.
Okay, so that's 5. Okay. What's the length of each of these edges going to be? 4. Because it's a radius. Each of those edges are the radius of the circle. Okay. So this would be 4, this would be 4, this would be 5. So the total would be 13. He needs 13 inches of decorative tape for each coaster. So arc length, you use n over 360 times 2 pi r, or if it's in radians, whatever the radians is times the radius. Okay. To find the area of the sector, it's n over 360 times pi r squared. We're not going to use the trig formula for that one. And the segment area equals the sector area minus triangle area. That's what we're doing today. Okay? Circles. I will leave those 3 formulas up there. It'll be just fine.
I like that circle formula better.
Let me get the assignment up to you.